Today, we're going to talk about wireless EV charging. Now, we already know there are some challenges that exist with EV charging, but let's look at a different solution. What if we were able to just roll over a pad and charge our vehicles? Pretty light lift, right? Now, we already know that, electric vehicles are changing the way that we think about transportation. But like I said, they can still be a hassle. So now innovators are actually looking at wireless charging solutions. So instead of plugging in your EV, you would simply park over a charging pad and then the battery would power up automatically. This technology is actually being tested in urban areas and could make EV charging faster, cleaner, and more convenient. The core technology behind wireless EV charging is inductive charging. So, a charging pad is installed on or beneath the ground, and it contains a coil that generates an electromagnetic field. Now, your EV is going to have a receiver coil, and it picks up this energy and then converts it into electricity to charge the battery. There are some advanced designs out there that can even deliver power efficiently if the vehicle isn't properly aligned, and that would reduce user error and make the process more seamless. Some systems are also bidirectional, so that means that they can support vehicle to grid technology and allow EVs to return energy to the grid during peak demand hours. Wireless EV charging has come a long way in recent years, but engineers are constantly tackling challenges like efficiency, scalability, cost. So, for instance, high frequency inverters and advanced magnetic alignment systems are improving energy transfer rates, bringing efficiency closer to traditional plug in chargers. And companies are also experimenting with dynamic charging, where vehicles can charge wirelessly while they're driving over specially equipped roads, potentially extending driving ranges on the go. These innovations aim to make wireless charging practical, not just for personal vehicles, but also for public transportation. So, fleets, delivery vans, even autonomous vehicles. Pilot programs around the world are testing how wireless charging fits into urban infrastructure. So, for example, in Oslo, Norway, taxi ranks are being equipped with wireless pads to enable quick and easy charging between rides. And even in South Korea, public buses are using wireless systems to recharge at bus stops, which reduces downtime and increases operational efficiency. Parking garages, shopping malls, workplaces, they're also exploring this technology because they want to create convenience and they want to encourage people to, get an EV. Now, wireless EV charging does offer clear benefits, right? It eliminates the need for those bulky charging cables, it reduces wear and tear on connectors, and it makes charging accessible for people with mobility challenges. And when it's integrated into everyday locations like parking spots, it can drastically reduce charging related inconveniences. But there are hurdles to overcome always. Current systems can be more expensive to install than traditional chargers, and they also require standardization. So all EVs can use the same pads regardless of the manufacturer, right? Plus, efficiency losses and energy transfer still exist. There are some new designs that are narrowing the gap, but despite all these challenges, actually the future looks pretty bright, and analysts predict that wireless EV charging market could grow to over $1 billion by 2030. As production scales and new technologies like resonant inductive coupling emerge, costs are expected to drop, and this would make wireless charging more accessible to more drivers. Now, integration with smart grids could further enhance the system, and this would ensure that EVs charge when energy is cheapest and most available. Wireless charging isn't just about convenience, it's about shaping a smarter, cleaner, more efficient future. So let me ask you, what do you think about this technology? Can it take off? What challenges do you see, especially from a technical perspective?